The list just goes on and on. However, there have been some very, very big attacks in the recent past. So you probably all remember the public sector attacks on the NHS recently with WannaCry a couple of years ago. But more recently, the Police Federation was also hit, which saw significant amounts of data deleted. More importantly as well, the scale of some of these attacks can be enormous. There's a malware issue with more than 100 banks worldwide, resulting in data losses and financial losses of more than £650 million. And last year, I think we saw one of the largest data breaches affecting customer details, and that affected the customer details of more than 500 million customers, as Marriott unfortunately discovered that they'd had a data breach which had been running for several years. The government is very much committed to spending more money on cybersecurity in 2018 and 2019, particularly to defend the NHS and other critical services. And of course, you all know that GDPR regulations came into force from May last year, and that really upped the ante on cybersecurity globally. There are now extremely large fines, which I don't need to tell you about, hopefully, for data breaches. They can be 4% or more of global turnover, or £20 million. And the reality is that although at the moment the ICO and their European counterparts are really only looking at the gross data breaches, they are starting to show that they have teeth, and there have been some very sizable fines levied over the last few years. So there's a lot of data here from very large companies, but I just wanted to pick out some of the interesting statistics that I've seen as I've been doing my research over the last few years. And some of these numbers are actually really quite frightening. So scarily, 55% of UK companies suffered a cyber attack in 2019 so far. That's a truly terrifying statistic. And despite that, 3/4 of UK firms have been rated by the National Cybersecurity Centre as cybersecurity novices. 60%, more than half of UK companies, rate phishing as their largest cybersecurity concern. And yet nearly a quarter of UK companies have absolutely no staff training in place for cybersecurity. But then for me, some of the biggest and probably scariest numbers that I've seen, on average, it takes companies 197 days to notice that they've had a data breach. That's 6 months where people have had full access to your IT infrastructure, where you've been leaking data, financial data and customer data, without you even knowing about it. And then typically, because cyber criminals have been in your system for such a long time, it can take many months to work out how they got in there and what to do about it and to seal the data breach. And that's why, on average, the cost of a major cyber attack is now $3.68 million, and that's going up very rapidly. That was $2.48 million last year alone. So this number is growing the whole time. Now, of course, a lot of these numbers here are taken from big companies, but actually the reality for SMEs is even more stark. A report recently from the legal industry stated that nearly half of SMEs who suffer from a major data breach are going to go out of business within 2 years. And the reality is that insurance is no solution. Even if they will pay out on a claim, which is by no means guaranteed, would you work with a company who's just lost all of your data? So I'm going to spend a little bit of time talking about what the best practices are and what the different options are available for protecting yourself against cyber criminals at the moment. And I've roughly categorized the technologies that are out there into approximately 5 areas, which I'll go through in a little bit more detail now. The first, and probably the most common type of cyber defense, is typically known as endpoint protection, or more commonly to the layman known as antivirus. Effectively, that uses blacklisting and heuristics. Sometimes people are claiming techniques such as artificial intelligence or deep learning. And pretty much what endpoint protection does is it's looking at spotting known bad patterns of behavior and bad patterns of code. So it's looking for faults or for cyber attacks that are similar to ones that have happened before, and it can then block those attacks. Encryption. Encryption is very important, but a lot of people seem to think that encryption is rather more powerful than it is. Now here, under this general heading, I've included both virtual private networks, VPNs, and also disk encryption. VPNs, for example, are extremely good at protecting data from snoopers as it moves over a network. Disk encryption, or encryption at rest, as it's probably more accurately called, is used to protect data that's on a hard drive, and it's fantastic for protecting a laptop or a USB data stick if it's been lost or stolen, since the thieves can't access data without the secure key. but it does have significant weaknesses. If your computers get hacked, even if they are encrypted, the first thing that you do when you log onto your computer is enter the password in order to allow your laptop to decrypt itself. So encryption only serves a limited amount of benefit in cybersecurity. Next area I'm talking about a little bit is border security. And there are lots of different things included in border security. Everything here, which a lot of companies will have in place, including firewalls, password managers perhaps. Two-factor authentication is becoming increasingly critical for central systems. But actually in this area, I also include other techniques such as vulnerability scanning, penetration testing, and similar things where people are testing your infrastructure to see if they can find obvious holes and obvious security weaknesses. The next category to look at is what I've called here network intrusion detection systems. They're typically looking for bad traffic on a network. And these are fantastic for stopping brute force attacks where an attacker tries to crack passwords. But some of these systems, the more advanced ones, can also be used to detect viruses or malware as they move around and travel through a network before they get to the endpoints, which they ultimately try to infect. But it's important to mention that virtually every network intrusion detection system out there actually relies on blacklisting technology, very, very similar to the endpoint protection and antivirus. So ultimately, although it offers protection in a different place, it offers fairly similar protection. Lastly, whitelisting, which I'll come on to in a little bit more detail later. This is probably the least used of all of these systems out there. Essentially, what whitelisting does is it provides a pre-authorized list of what's allowed to run on your servers, and it then blocks everything else. And that can be great for servers where you're in control of what's running, where you really know what's on there. Apologies, we've got a lot of feedback on that particular line. Hopefully that will cease in a minute. So whitelisting can be great for protecting servers where you're in control of what's running. The interesting thing is, though, that virtually all of the businesses that I talked about earlier that have suffered from major data breaches over the last few years have had in place antivirus, firewalls, encryption, two-factor authentications, and dozens of other technologies. The reality is, though, it's not enough. Pretty much all of those companies had those, and they were still compromised. But the observant amongst you will hopefully notice what's been in the background of an awful lot of my slides: people. The reality is that cyber criminals are using the weak link in our security systems, people, and they're using that instead of going head on against our IT defences. They're tunneling under the walls, they're working around them. A good example of this, there was a recent issue in Salesforce, which, whilst technically not actually a cyber criminal, a single mistake by a system administrator in Salesforce led to users all around the world being able to access critical account details from dozens of other companies. And that led to a huge shutdown in Salesforce and a very large amount of egg on their face, which lasted at least 15 hours while they attempted to rectify the situation that one simple mistake on behalf of an important person had caused. The reality, therefore, actually around cyber criminals and data breaches, it's not a case of if we're going to suffer a data breach, but when. So I've talked a little bit about the technologies that different people use and mentioned that obviously these technologies can only offer a limited amount of protection. So I'm going to talk a little bit about the kind of techniques that cyber criminals actually use in order to breach your defences and show you how some of these defences can be used, but actually how there is really no panacea. There's no one technology that will solve all of your problems. So perhaps I'll start with the simplest form of a cyber attack, a brute force attack. It's essentially, this is where a criminal will use a bot to throw an entire dictionary at your server in an attempt to break a password. Here, antivirus won't help because it's not actually a virus. The easiest way of securing this particular problem is to use strong passwords as it happens, so it's fairly easy to avoid this ever becoming a problem for your organization. But of course, people's definition of a strong password can vary somewhat, and dictionary words with O's and I's replaced with ones and zeros are not good. They're pretty much the first thing that all automated botnet attacks will actually attempt. So don't assume that that makes for a strong password. That said, even if you do have weak passwords in your system, it can still be very easy to spot. Most firewalls and network intrusion detection systems that are well set up will have logging in order to detect if multiple login attempts have been made to a single server, and they can stop those attacks dead in their tracks. You've probably seen that a lot of your own personal online accounts will only allow you to attempt to log in 3 or 4 times, maybe 5 times, before they will block it and make you wait several minutes. So that means that actually brute force attacks are fairly easy to fix. More importantly as well, of course, two-factor authentication, for example, where in addition to using a password to log on, you may, for example, have a code sent to your mobile phone. That again will stop brute force attacks pretty much dead in its tracks. So this is probably one of the easiest attacks to stop, but it's still worth bearing in mind. Some people still fall foul of this because of poorly protected systems. And probably the second most common form of cyber attack is a drive-by download. It's probably one of the most common forms of malware. And typically what will happen here is that a user will accidentally click on a link on a website or an email, and for example, the website may be infected with malware. And the criminal here is hoping to exploit weak cyber defenses. They're usually fairly easy to defend against because the malware used in most of these attacks, by the very nature of it, has to be fairly generic. Good quality endpoint protection will usually pick up these issues and stop them. Interestingly though, two other defenses that people often rely on will help very little in the case of a drive-by download. Firewalls are almost entirely useless, since the laptop that you are looking to infect is already inside the company firewall. Likewise, encryption is going to offer little or no protection here. VPNs, for example, will just happily encrypt the virus or the malware and transmit it over to your laptop, where it will be decrypted and run anyway. And likewise, disk encryption won't really help, since you've already entered the password on your laptop to tell it to decrypt the disk when you logged on. So even a simple attack like this, some of the technologies that we use won't defend against. WannaCry is a very good example of self-replicating ransomware, and actually they get an awful lot of press, but typically they start from the same problem that we just discussed previously. They start from a drive-by download. After that, some of these self-replicating ransomware cases can exploit known Windows vulnerabilities to spread inside your network. For example, WannaCry was making use of a legacy piece of code in Windows file sharing systems that allowed it to replicate onto multiple different machines once it had got a foothold inside your network and inside the firewalls. Again, though, the key thing is here is that, again, firewalls are not really going to help here. Border security really doesn't help you because it's exploiting a vulnerability in your systems, which is already inside the major security. Now, of course, the best way to protect against most self-replicating ransomware is to make sure that your software is always permanently patched. Again, endpoint protection, if it's chosen well, will usually pick these up. Again, they get a lot of press, but actually they're pretty easy to stop in the grand scheme of things. But then we can come on to some of the slightly more problematic forms of malware that cyber criminals are increasingly moving towards. Now, as it happens, self-replicating malware often exploits a vulnerability in the operating system of your IT in order to spread itself. WannaCry is a good example of that. And the most common threats are pretty well covered by endpoint protection. The problem is that new vulnerabilities are being found the whole time. It's very much an arms race between the cyber criminals and the antivirus vendors, and the reality is that it's one that can't be won. Brand new vulnerabilities are being found by the cyber criminals first, and if they're careful, they can use these vulnerabilities to hack and compromise multiple systems before the vulnerability is more commonly reported. And again, they can be inside your system for an extremely long time before you notice them. Eventually, your antivirus software will probably spot them, but is it already too late by that point? Again, encryption's no help. Border security has already been breached in this case. If the criminal is careless, they might do something like download vast quantities of data really quickly, and that would trigger a well set up network intrusion detection system. But criminals are not typically careless. If they're clever enough to exploit a careful, newly discovered vulnerability, they'll be careful enough to work around all of the things that would trip your network intrusion detection system. And that system would just see data flowing around the network. It can't tell the difference between good and bad data flow. Whitelisting, on the other hand, can pick up this type of attack. The reality is that once a criminal uses a vulnerability exploit that is already in your systems, they invariably use this to change something on your server. It may be one line of configuration, as was the case with the British Airways hack last year. However, that change, if you're using a whitelisting system, would instantly be flagged and give your security team the ability to look in detail at what's changed and why. Another advanced technique that cyber criminals are starting to use to get inside your systems and get that first foothold in your system is spear phishing. I mentioned earlier that, of course, the biggest vulnerability that criminals exploit are people. Spear phishing is actually an increasingly common tactic for cyber criminals. They can be extremely clever and very convincing, sometimes fooling even the most savvy IT professionals to get us to divulge critical information. I personally had an example of this a couple of years ago. I received an email from my marketing director talking about a new product launch. The dates, the times, the facts about the launch were all correct, and he wanted me to look at a document that was attached to an email. The only reason I was suspicious about this particularly is because the marketing director happened to be sitting next to me at the time, and so I asked him if he'd actually sent this email, and of course he hadn't. It was a spear phishing email, and the attachment that they sent me was full of bespoke malware that was specifically aimed at trying to relieve me of my passwords and credentials. You're not going to stop the criminals getting in. They're going to find increasingly sophisticated ways of getting in, and sooner or later, with any sizable organization, somebody is going to make a mistake. Even the best of us make mistakes. So the key thing that I'm trying to bring forward here is that the most important thing is to recognize that people are going to get through your defenses and do whatever you can to spot them once they've got in. Remember, I said that on average, it takes companies around 6 months to notice that they've been hacked. This is where whitelisting can really be an excellent final line of defense. As soon as they make an unauthorized change on your servers, you'll know they're inside. And once they're inside the servers, you can pinpoint what vulnerabilities they use to exploit and how they manage to get in there. And you can cut the detection time from months to minutes. And by cutting that time to detect that they've been in there to minutes, you can massively reduce the cost of rectifying the situation. Finally, I just wanted to point out one of the last and almost most difficult types of cyber attack to spot, and that's the insider attack. Again, whitelisting, actually, it's not just external attacks that can be spotted by whitelisting. You can actually potentially, if you've set up the systems and processes correctly, you can actually spot a malicious attack caused by an insider in your own company. I came across an example a couple of years ago with one of our customers. It's a customer who was running an online poker game. And one of their system administrators had made a small modification to the servers that allowed them to cheat at the online poker game. And by using that cheat, they siphoned vast amounts of money out of the company by playing the game. If they'd had our whitelisting technology installed at that time, they would have spotted that change instantly and spotted that it was unauthorized. As it was, it took them several years to spot it. And it was actually only a mistake on behalf of the criminal, the system administrator in this case, that allowed them to spot it. The guy was dumb enough to drive up to work in a really expensive car, and people started asking questions. So again, you've really got to remember that actually spotting these cyber criminals can be extremely difficult unless you've got the right technologies in place. So I've been talking for a few slides about whitelisting. So I thought I'd probably talk a little bit about what whitelisting is and actually our concept of distributed whitelisting and how this can help you and what it actually does in detail. This is probably the type of cybersecurity technology that's least familiar to most people because it's infrequently used. We have a patented concept called distributed whitelisting, and it's built essentially on a cryptographically secured audit trail. Every few seconds, we create a digitally signed audit trail of everything that has run on your servers, wherever those servers are, whether they're in your own IT infrastructure or whether they're in the cloud. It will then transmit that digitally secured audit trail across to a series of verification servers. Those verification servers will compare what's actually run on those servers to a whitelist saying what's allowed to run. And that means that any discrepancy will be instantly flagged. And using this technique, as I mentioned, we can detect in seconds if anything's run on your servers that couldn't be there. There's a couple of really important things that I'd like to point out here. The first thing is that actually this whitelisting technique is virtually impervious to hacking in itself. We use hardware-based cryptography, which is seated on the motherboard of virtually every server that already exists. It's a chip called the TPM chip. And by digitally signing that audit trail, it means that it's not in itself susceptible to tampering as it moves across the internet. So you can't tamper with that audit trail. If you stop the audit trail in its tracks, the verification servers will pick it up. If you modify it, the verification servers will pick it up. By having the verification servers independent of the servers that you're attempting to protect, it also means that you can protect against a human failure. You can actually have the people who are looking after and administering your primary infrastructure completely independent of the people who are looking after the verification that that server hasn't changed. So no single mistake on behalf of a human could cause a change in your infrastructure that you wouldn't notice. And uniquely, we can also actually place the verification infrastructure anywhere in the world. And that allows us to eliminate even that final point of failure. Even if you're running your servers in the cloud, for example, if your verification servers were being run in the UK, but your cloud services were being hosted by Amazon in the US, Amazon themselves couldn't actually tamper with your servers without you, the customer, knowing about it. And this can really give senior decision makers peace of mind. There are numerous advantages to our technology. Obviously, critically, the architecture prevents any one slip from compromising the integrity of your servers, so you can eliminate human failure. You can also protect against malicious intent. However, the important thing to bear in mind here is that the key thing that we're aiming to do here is we're aiming to detect those cyber criminals once they've got through the rest of your defenses, and that can be really critical. Several of our customers are seeing this technology as extremely valuable, and we've now recently been selected to provide the cloud services for an entire overseas British territory. And all of those territories will now be running on platforms that are hosted by CyberHive. It's also worth mentioning that, as I said, this technology has been patented, and we've actually been granted a continuing grant to work with Oxford University. So Innovate UK and Oxford University are working on us in order to continuously improve and take this technology into new areas. And just a very brief overview of the roadmap. This technology, as it stands today, is currently available to protect any Linux servers. Whether those servers are on-premise or in the cloud, we can secure them. We're looking to extend this technology to protect servers in public cloud platforms as well, so that we can get an even more in-depth protection, for example, on Microsoft's Azure platform. We can protect servers, and ultimately we'll be able to protect them to levels that haven't been seen by any other technology. At the moment, this technology is available on Linux, but we're also continuing the development, and this technology will be taken forwards onto Windows in around 2020. And we also have future technology roadmaps that will allow us to do other clever things down the line, including full disk encryption and actually full encryption of running servers. Okay, so I've talked about whitelisting, and I've talked about whitelisting quite a lot. Is this a magic fix-all? Well, no, of course not. There are plenty of applications where whitelisting simply isn't appropriate. It can't protect your laptop, for example. It's just not appropriate for that technology because it changes too often. And I would always advocate that you should have antivirus software, you should have firewalls, you should have two-factor authentication. Most importantly, you should have proper staff training to make sure that people are not getting into your critical systems in the first place. But the reality is that despite all of these things, problems are going to happen. And I would seriously recommend that you consider whitelisting and every other technology that you come across for your business. Sooner or later, criminals are going to get through your best defenses, and then how long will it take you to detect that you've got them? How much data and money will you have lost in the meantime? We'll be in touch by email shortly after the webinar, and hopefully we can help to improve your cybersecurity. But even if you don't end up working with us down the line, we hope that by listening to today, it's given you some food for thought and helps to move your company forwards. Our final ask of you is, if you're in an organization which carries massive amounts of client data, whether it's online retail, banks, financial services, maybe you're in an organization that's highly protective of its IP, such as pharmaceuticals or tech companies, or if you're responsible for national security, military or critical government, we'd love an opportunity to discuss with you how we can prevent your business from becoming the next headline. I'd like to say thank you all very much for listening.